Good day, students. On this clip, we're going to be going over how to graph parent sine and cosine curves. So let's go ahead and write down the instruction for the notes. So we are to graph the given functions, on the specified domains, Okay. All right. So number one, we're going to be graphing y equals sine x. This is a parent sine function on the domain negative 2 pi is less than or equal to x, and x is less than or equal to 2 pi. Okay? All right, so why do we call this the parent trig function for sine? Y equals sine x is a parent trig function because it has no transformation whatsoever. Okay? Now you can imagine that there is a 1 right here, and there is another 1 right here. Okay? So this one in front, the coefficient of sine determines the amplitude. Whatever number here, yeah, the coefficient of sine determines the amplitude. Okay? And for the parent trig function, you can clearly see that the amplitude is 1. Okay, the amplitude is 1. Basically, that means that you're going to go up and down 1 unit. Okay, you go 1 unit up and then 1 unit down from the central position. When you go 1 unit up, you end up at the maximum. When you go 1 unit down, you end up at the minimum. All right? That's what the amplitude tells you. So for the parent trig function, the amplitude is basically 1. All right? And then this value right here tells you what you divide the period, 2 pi by to get your period. So if it's 1, this tells you the period. So the denominator of your period, so of 2 pi, which tells you your period. So here we have the period is basically going to be 2 pi divided by that number, which is 1. Okay? So for the parent trig function, parent uh, sine function, we have the amplitude. Amplitude is 1, which basically means you're going to go up 1 and down 1 from the center. And your period is going to be 2 pi. Okay? And this one goes side to side. And it also tells us something about the calibration, which basically is how many quadrants is going to yield this. So if you think about your coordinate system when you're graphing your side function, let's draw a coordinate system. So here goes your coordinate system. How many radians completes a full cycle? You have 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so to get 2 pi, which is the period for this particular parent trig function, we have 1, 2, 3, 4 quadrants. Okay, so to ensure symmetry in our graphs, we're going to let 4 tick marks equal a period. Okay, so for this case, we're going to let 4 ticks along the x-axis equals 1 equals 1. So 4 ticks equals 1. 4 ticks equals 2 pi. Okay, 2 pi or 1 period. Okay, so 4 ticks equals 1 period, which is the same thing as 2 pi. All right, so we're going to use all this information to generate our parent sine curve. So let's create our coordinate system. That goes say a little bit longer. My y-axis, and there goes my x-axis. So the calibration of my x-axis, as I mentioned earlier, I'm going to let 4 tick marks equal 2 pi. So let's use 2 boxes for a tick. So 1, 2, 3, 4. Okay, so that's 2 pi right there. That basically tells you that this is pi over 2, and this is 3 pi over 2. Okay, same to the left. 1, 2, 3, 4. That's negative 2 pi. Because the problem asks us to go from negative 2 pi all the way to 2 pi, okay? So that's what we're going to be doing here. To get a max and a min, let's use 3 tick marks as a max. 1, 2, 3. So from the center, remember the amplitude is 1, so this is going to be 1. That's the max, and 1, 2, 3 down to negative 1, that's the min. So we're going to have we're going to draw the maximum and the minimum, okay? All right, so this is our maximum. A dotted line, since it's not the graph, through the maximum point, maximum displacement. And this is the mean, a dotted line through the low point, okay? So there goes your max, and there goes your mean. Now we're going to start graphing the points for our parent sine curve. Now, this is the y, this is the x. Remember, the sine curve, sine, remember it starts with an S. It looks like an S. So let's say this is your coordinate system. You start from the center, and one complete period looks like an S, okay, for your sine curve. And for your cosine, let's say this is your coordinate system. One complete period, see the C looks like a cup, so it's something like this. All right, so that's the difference. Sine starts from the center, forms an S. Cosine starts from the max and forms like a cup. All right. So let's go ahead and graph the points that's going to guide our graph construction for the sine. So since it's an S starting from the center, we'll always start plotting our points from the y-axis. So starting from the center, you make a point. Next tick mark, you go to the max. So let's label that max and min. So this is our max. This is our min. This is our center. Okay. All right, so you start from the center, one tick mark, go to the max, one tick mark back to the center, one tick mark to the min, and one tick mark back to the center. All right, so we'll go as far as 2 pi as indicated in the problem. And we'll do the opposite to the left. One tick mark takes you to the min, one tick mark back to the center, one tick mark to the max, one tick mark back to the center. Okay, now let's go ahead and connect our dots, and that will be the graph of our cosine, our sine curve. Okay, so starting from the center, the slope at the center is 1, right? So make sure you go out straight out of the center. And the slope at the max is 0, so you have to curve at the max, right? Curve out of the max to ensure the slope is 0. And then when you get towards the center, you're going to go straight through the center. And then you curve at the min, curve out the min, and straight to the center. Okay? So there goes the positive side. Now the left side, starting from the center, we're going to go straight out the center. And then curve at the min, curve out the min, and then straight through the center, and then straight out the center, and then curve at the max, curve out the max, and straight through the center. Okay, so there goes your sine curve. Now, since there's a line on these two inequalities, that basically means we're going to close the endpoints are included in our graph, in our solution graph. So we have to make a closed circle here and a closed circle here. And this is the graph of y equals sine x on negative 2 pi less than or equal to x, and x is less than or equal to 2 pi. Okay? All right. Now let's move on to question number 2. On question 2, we are to graph y equals cosine x on the same interval, negative 2 pi is less than or equal to x, x is less than or equal to 2 pi. Now this is a parent cosine function also. You notice there's a 1 here and there's a 1 here. So the amplitude, max min, is 1 also, because you have, imagine there's a 1 over here. And your period is 2 pi because you're dividing this by the 1 that's in front of this x, okay? So this is 1 going up and down, and this is 2 pi basically means 4 ticks is going to be equal to 2 pi. All right? So we're going to use these two pieces of information to guide our construction of the curve, okay? So let's go ahead and do it. So let's graph our axis. There goes my y-axis. And there goes my x-axis. Let's go ahead and calibrate the x-axis first. So for the x-axis, we're going to have 4 tick marks equal 2 pi as indicated here. So 1, 2, 3, 4, that's 2 pi. That's a complete period. Center is pi, 2 pi and 3 pi over 2. And then 1, 2, 3, 4. This is negative 2 pi. This is negative pi. All right, and then the max is going to be at 1, since the amplitude is 1, and the min is going to be at negative 1. Okay? All right, so let's go ahead and graph that. So change this. All right, so this is our maximum, and this right here is our minimum. Okay? Now remember the orientation of your cosine curve, right? Let's go over that again. For sine, remember sine starts with an S. So from the center is like an S for one complete period. For cosine, C like a cup, right? So for the cosine is like a cup from the max forms a complete cup, and that's a complete period for your cosine curve. Okay? So the cosine looks like a cup, as you can see here. Imagine a cup that you can fill water in at this point. So this is what it looks like. So this is your cosine, and there goes your sine. All right, let's go ahead and graph it. So let's graph. We have to graph the points first that determine the construction of our cosine curve. So this is the max, center, mean, center, max. Okay, notice I start from the max because I'm going to be creating my cup in this orientation. And then going to the left side, max, center, min, center, and then max. Okay, now let's connect the dots. Remember, you always go straight out of the max. I mean, you have to curve out of the max and the min, and you also have to be straight at the center. Okay. All right, now let's start from the maximum. Remember, the slope at the maximum point is 0, so we have to curve out the max, straight towards the min, straight out the min, straight out the center, curve towards the min, curve out the min, straight towards the center, straight through the center, and then curve at the max. Okay, so there goes your first period of your cosine curve. Doesn't look too good. So there you have it. And on the left side, the same thing. You curve out the max, straight through the center, straight through the center, curve at the min, curve out the min, straight to the center, straight out the center, and then basically curve at the max, and there goes your cosine curve. Okay? So this is the graph of y equals cosine x on the interval negative 2 pi less than or equal to x, and x is less than or equal to 2 pi. All right, so just remember your orientation, and that should guide your construction of your parent trig functions. So thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel by clicking up here. If you like the video, you can click like down here. Please post a comment. Tell me what you think about this video clip. More videos can be found on mathgotserved.com. Thanks again, and have a wonderful day.